I'm gonna go ahead and turn on the YouTube stream. Should be going up. That's the temporary one. If you open up the participants list, there's a raise hand button on there. And I think that one's a more permanent one.
Hitting on one of the officers. We have a number of the other officers here on the channel, Eric Sowell, Russell Durham, and Justin Williams. I don't know if Darren is online right now. He may be on in a little bit. That would be Darren White. So we've all been officers. We've been around the user group for quite some time. Actually, Scott Dockendorf used to be one of the officers of this user group some time ago. And so it's really great to have him back and have him speaking. So with that, I will just hand it over to Scott.
Awesome. Thank you, David. Sorry, I'm getting all of the, got so many windows open. Awesome. Hello, everybody. Thank you so much for taking time out of your evening to meet with us. I promise to deliver an efficient session. And really, the goal is just to demonstrate the kind of the awesomeness of a micro-ORM and Dapper. I see some familiar names. It's good to see some folks. For those that I haven't had the pleasure of meeting, my name is Scott Dockendorf, and I'm currently heading up technology for a company called Remote Operations. There you go. So a little bit about me. I'll take 2 seconds for this. So I'm a proud husband of two. I'm sorry, a proud husband and a father of two. Wow, that came out wrong. I love music. I'm a drummer. I love live music. So I listen to a wide range, but I tend, especially the live shows I go to, I tend to be more like towards the rock and metal scene. That's a picture of me, myself, and Rob and Mark from the Filipino metal band Death Angel. I got to meet them back in 2019, you know, pre-COVID. Anyway, so yeah, as David mentioned, I've been a volunteer of user groups. I've had a strong passion for helping out with user groups. I started with Dallas, and then I had an opportunity to work with some folks here that are heading up this group. And so, as a program director for what 4 years here with this group, and currently the program director with the Dallas group. But again, I'm just I love giving back to the community and however we can, and it's just nice that we take the time and have the opportunity to attend sessions like this. So again, thanks for joining. I've been developing for over 25 years, and I've been with .NET since the 1.0 alpha. So a little bit about the company, which I hope sets the stage for why I was motivated to for this presentation. So I work for a company called Remote Operations. Our platform is called DocFluent. We're a healthcare technology SaaS provider. We partner with healthcare facilities, hospitals, and specific care facilities, where our organization will take over the management of much of the tedious processes that some of the practices have to deal with today. So for those of you that are in healthcare, you may know this, and for those of you that aren't, you'll be shocked at how much faxing is still a part of healthcare today. But we'll take medical records, transcriptions, fax management, external reports, records requests, et cetera, and we'll manage those for our clients. So ultimately, we want our clients to, if we can take that on for them, they can focus on what's most important, which is patient care. We've been in business for 14 years and growing. Because of this growth, we're digging into some modernization efforts. So we kind of have a wide range of technology, but and for us, instead of having like a ginormous modernization project, we've been able to tackle it in bits and pieces, and we've been able to dive in and address performance and adjust some things. With this growth, really the motivation for this talk, I'll take a step back. So I've been lucky enough. I've used Blazor. I've used Dapper for really the past past couple positions or past couple companies I work for. I've used Dapper in the past, but it wasn't until this one. Like in the last company, we actually built we had a cybersecurity portal that we built, which was largely lots of reads, a little bit of writes. So we actually ended up building our infrastructure layers so that Entity Framework was what we used for writes, and Dapper is what we used for reads. And then I supported other applications that were built in Dapper in the past. But what happened for us is, as we've grown, we had some back-end Windows services that were taking longer and longer to run. And by the time I started until, fast forward a couple of years from now, we look back and some of these processes were taking anywhere from 24 to 32 hours to run, to complete these long running processes. And so we dug in and we said, you know what, those are all using like a legacy COM component for some of the data access that's still calling store procedures behind the, under the covers. So let's go ahead, let's just convert all those to Dapper, right? So we can still use, we're in .NET, they're Windows services. We can leverage, replace that legacy COM component with Dapper, and we were able to reduce the runtimes from that were at 24 to 32 hours down to 45 minutes to a little bit over an hour. So the intention to say that is not to brag or try to pat myself on the back, but it was like we couldn't believe that what a difference Dapper made for our performance. And what we learned was that this legacy COM component and those old components were apartment threaded, didn't really leverage true multi-threading, and they used components where you had to traverse the object sets, the scripting dictionary, where the performance degradation was almost like a hockey stick on a graph, where it continued to have poor performance the more records you ran into it as you were traversing through each entry. So Dapper made it was a huge win for us. And so we've been able to leverage Dapper in a wide range of projects. We've been able to leverage it in Windows services, API layers that fuel other websites, and utility apps and other functionalities. So anyway, it's been an awesome the ability for us to leverage Dapper to access data very quickly and map things to object, because we're all developers, right? We don't want to deal with data sets and data readers and all that. We want to be working on the object level. So it gives us a chance to do that. So the goal for this session, if you're new to ORMs or micro-ORMs, so I just want to introduce that concept. Try and put together an introduction for Dapper, where the code samples are going to be those common things you'll need to, in order for you to use Dapper. I want to tackle things like querying, getting multiple results, getting a single result, looking at inserting and updating data, and how do you manage transactions within Dapper? How do you get return values? If I insert a record, I need to get that identity back. How can I do that? So I want to be able to show some of those items. And then lastly, I've got a few thoughts on when does a micro-ORM help, and some advanced topics that some may have run into with transient errors and things like that. So before we begin, I just wanted to ask if everyone could, in Zoom, click on the participants window, and there should be a button at the bottom for raised hands. And I wanted to ask, excuse me, man, I got coughed. First, how many people are using or have tried to use or have spent some time in Dapper? If you can just raise your hand, I'm curious. Okay, cool. How about Entity Framework? How many Entity Framework folks do we have? Yeah, some more. Okay, great. And then how many folks are how many folks are actively working on .NET Core or .NET 5 solutions? Okay, good. Well, the good news is, for those that didn't raise their hand to that last question, Dapper can be leveraged in .NET 5, .NET Core, or .NET Framework applications. You're not limited to .NET 5 from that perspective. So, great. Thank you, guys. Okay, so let's. So I just want to take a few minutes. There's a handful of slides to start. We'll do a bunch of time in demos, and then I have a handful of slides after that. So first, I just want to start with data access. So time and time again, much of the applications that we write, what are we doing? We're getting data. We're displaying data. We're allowing you to edit that data. We validate it, and then we save it, and then we kind of repeat the process. So when it comes to data access within .NET application, there's three common approaches to this technical challenge. First, I'm sure many of us have had to do this. We can roll our own ADO.NET code. So this is where you're working with the native objects in system.data.sql client or Microsoft.data.sql client using SQL Server as an example, where you're building this logic. It's getting cold in here. Where you're building logic with the raw .NET. Now, it's great because it allows you to get down to those lower level areas, but for many of you, for all of us, if we want to work in objects and collections of objects, you've got to build all that kind of plumbing for the manual mapping of the data sets or the data readers into the objects that you'd like to address. So one modern technique is to implement an ORM, or an object relational mapping tool. So here you're living in native custom objects in C#. So there were about a third of you, I think, that raised your hands for using Entity Framework. So you're probably well familiar with this. But with an ORM, your database is modeled to a series of object-generated code. You can use SQL, but often you're not really spending a whole lot of time in SQL. Rather, you're relying on LINQ or Lambda or whatever it is to find and access to your data. Now, the ORM system will have mapped your objects and your relationships into that generated code. So the objects have is-dirty, change tracking. The data can be easily inserted or updated with persistence calls. Database changes are handled by migrations, which are C# classes that allow you to adjust your database objects as necessary, adding columns, extending column, varchar column lists, adding an index, etc. For some individuals, this works great. This could be, it can be a fully functional implementation, but to others, it may sound like, oh, either, I've heard, oh man, it's overkill. Like I have an existing database. I just want to run queries. I just want to, tackle, and ORMs may feel like a big, getting over that initial hump to implement it. I'm not, and I'll share with you in a minute. I'm not saying it's bad. I've used both and I've leveraged both, and they both have done, they've helped us realize what the application was trying to implement, or what we were implementing with the application. But the kind of happy medium in between the two is a micro-ORM. So the team with Dapper said they just wanted to target what they call the 95 percentile. And that is, they wanted to be able to query data, they want to be able to execute commands very quickly, and then map the results to objects. That's what they want to solve. They don't want to solve, the intention isn't to solve all the other things that an ORM provides for. So that's where, so I have a few examples of ORMs and micro-ORMs under there. And the two we'll talk about more today, or kind of the two frequently used ones in the .NET space, would be Dapper and Entity Framework. So this chart, we'll talk about this after the demo, but essentially here's a little, additional details provided. But if you look at the column on the right, excuse me, if you look at the column on the right, that's Dapper. Again, it wants to have that object mapping with the plain old custom objects, the POCO objects, and execute queries and commands. Entity Framework, although offers, has relationship tracking, change tracking, offers a second level cache, designer, and et cetera. We'll come back to ORM in a minute. But for now, let's talk a little bit about Dapper. So Dapper is a micro-ORM created by the Stack Overflow team. So they, and we've all used Stack Overflow, right? So we know there's a tremendous amount of data in their system. In addition to caching, they want an ability to have blistering fast data retrieval. And then execution for commands. So it is compatible with all ADO.NET providers. So you're not limited to just SQL Server. You can use other database types. It'll work with those as well. There are .NET Framework, .NET Standard, and .NET 5 targets for Dapper. So you can, so you can leverage them again if you have an existing or new .NET Framework application or anything with .NET Core or Standard, and it's an open source license. So on Dapper's website, they talk about, I pretty much mentioned this, but their quote was essentially, we're not trying to solve every problem, we're trying to solve the 95%. Fake stat or not, but the 95% scenario is reading and writing and object mapping. So how Dapper works, essentially, it's a NuGet package that you install, and it exists as extension methods that are off the DB connection object. So there's an example of a few. I'll show you more while we're going through the demo. But those extension methods allow you to perform the actions. So Dapper is using, in a perfect world, the properties of your object, the names of the properties of the objects match what's being returned in the result set. If that's the case, Dapper will use, the dynamic method generation to map your result set to your native list objects with your custom. If your column names are the same, score, you'll be able to leverage it. If they're different, or you want to override those, then there's another Dapper, there's another NuGet package available for Dapper.fluentmap that allows you to adjust those field names. In addition, under the covers, Dapper is utilizing connection pooling. And then it also caches some query info so that it can hydrate those results into those objects pretty quickly. Some of the benefits to using Dapper are simply performance. Those that have leveraged it, there's some articles out where people have compared Entity Framework. I've got a few stats I'll show, but there's some have seen the performance for raw ADO.NET and Dapper are pretty close, but there are some scenarios where Dapper has shined over EF Core, and then some that it's better, but it's not tremendously. But I've got one example of each of those. But Dapper allows you to, it'll help reduce the amount of code. You can virtually get rid of the code you need for mapping to objects. And then your query command execution, you'll see in the demos, it's much shorter than probably what you're used to. Dapper does allow you to leverage the benefits of SQL. And so if you have, especially if you have an existing database, and that database may have lots of, the DBAs may have put together some abstraction layers so that they can control performance. So they may have lots of stored procedures, or there's business logic in there that you need to account for. It's pretty straightforward to implement that within Dapper. And then for us, again, I'll talk about it in a minute, but there are some believe that ORM play a certain role and micro-ORMs play a certain role. I don't know if I subscribe to that theory. I believe that if it can meet your objectives and if your application can be the enabler for some business feature, if you can make it work, then make it work. I think it can work out well. Here's an example. I referenced these articles that I found, but there's a couple of them. It's worthy to look into if you're interested. They talk a little bit about, especially if you're interested in EF core and turning on tracking and not using tracking. But in this scenario, it's 1,000 records, which is really an absolute blip, probably for some of the databases that we have all had to use and support and manage. But in this example, for what they had put together, Dapper, now those times are all in milliseconds, but Dapper was the clear winner by far from each of those entries. And there was another example where Dapper won in all different types of requests, but it was not as much as the last performance. So I think a lot of those, it all depends on, the types of actions you're attempting, the data that you're trying to reach. And there's always factors with databases. Are they indexed? Are there too many indexes where inserts are slow? But the retrieval's faster. So there's always so many factors that comes into it. But how do you get Dapper? I'll show you here in a minute with the demo. It's pretty easy. You simply add Dapper, a NuGet package, and for .NET Core and .NET 5, you'll eventually add a dependency to Microsoft.data.sql client. And that's it. So at that point, then you're really living in the C# world. So let's go ahead and jump in the demo. Okay, let me launch this virtual machine. So I put in a ref. While I want to jump in. Have there been any questions so far? Nope. Okay, good.
No, I haven't seen any.
Awesome. So if you find the demo interesting and you go, I'll provide a link to the GitHub repo. First, I wanted to share in the solution. There's a sample, the C# sample. There's the PDF of the slides, and then most importantly, I had a database script. So if you look at here, let me try this. Okay. So here, I simply found I wanted to get some kind of like a production database. So the fine folks over at SQLServerTutorial.net have a sample database called bike stores. So included, if you're interested in that project, included in that are scripts you can create all the once you create a bike stores database, you can drop all the objects if you want to start over, create objects, load data, etc. So I'm only using a portion of this for the demo. But it's there in case you want to kind of fully feature database that you can jump around in. So here I'll show you here. So what I have is I have SQL Server running locally. I have the bike stores database. In the database, there's two schemas. The way they've structured the data is there's two schemas. One is production and sales. So production, this is a bike, like a retail organization. And this has a back-end system that probably runs at corporate, because there's the production tables, which are really lookups, like what are the brands that we sell, what are the categories, and what are the products that we sell. The sales has customers, and the tables we're going to be looking at are orders and order items, which is a pretty straightforward concept. And then we'll do some updates to the brand table. But if we take a look, again, we have the sales orders. I'll do sales order items. So for many of you that have worked on retail or e-commerce type applications, this is similar to probably what you've seen before. Every order that's placed has a primary key, which is an order ID. We've got a foreign key reference to the customer. There's an order status. There's a series of dates for order date, required date, ship date. Here we have what brick and mortar store the order was placed at. And then staff ID is the is the sales associate that they place the order with. And then order items are what you can imagine. There's the reference to the order ID, and then here's the primary key for the item itself. What product did they order? How many of each product did they order? What was the list price and the discount? So this table actually doesn't have the actual line item cost. And so I'll show you, we'll derive that with a computed column. But anyway, so pretty straightforward database, probably something similar. So let's go ahead and start. What I wanted to do, we'll start with a clean project. I do have some items because I didn't want you to see me fumble over some of the typing. We're going to do, of course, some of the demos live. There's some that I'll copy over from the snippet. We're going to create a new project. And I'm going to go ahead and create a .NET Core console app. And I want to put this in. All right, I'm going to put it in a new folder called North Dallas. I'm going to call this Dapper Demo. I don't know about you. It kind of drives me crazy that in Visual Studio 2019, you create the project, and then for some reason, when it creates it, if I go to the project properties, by default, it's targeting .NET Core. So .NET Core 3.1. And so I want to be able to do it to 5. Let me go ahead and clean the solution and rebuild. Okay. Let me get my snippets in play real quick. So give me 1 second here. Okay. So now we'll go ahead and load the project. There we go. It takes a minute for those demo snippets to come up. Okay, great. So first thing I want to do, let me get a few plumbing items in place. So first, I'm just going to create just supporting methods to do logits, which is just nothing more than console write lines. And this is an example of, like, please don't do this in how you have your production code. So please don't keep your connection strings in plain text. Please don't place them in source code. But I didn't want to have to spend time doing all the plumbing. So for this purpose, I'm just going to leverage this connection string here. But please encrypt it and try to keep it out of the application somewhere else, right? In app config and KMS and in Key Vault and another area. But for this, I really want you to just focus on the Dapper piece. So, okay, so we've got a connection string. We have an application. First thing I want to do, I want to make this little checklist that we're going to use. So what I plan to talk you through, and we'll go through each one of these, but I want to show you, again, common functions you'll need to start using Dapper today or tomorrow, in case you haven't started using it before. So we'll talk about queries. So we'll start with queries. We'll talk about calling queries via text or stored procedure. We'll talk about getting multiple results. We're getting to talk about a single result. We'll talk about some common solutions around one way to get a parent and its child data with regards to order and order items. Then we're going to spend some time in updating. So we'll have some quick methods that'll show you how to update, whether it's a text and with a sproc. I want to introduce transaction management within Dapper. We'll talk a little bit about return values and then a nice little utility that allows you to perform you can insert multiple objects within a single command. And then we'll lastly talk a little bit about exception handling. And then I did want to present one approach that I started using at the last company that was just a way to structure your queries and commands that I thought was a kind of a neat little design trick. So I just wanted to share that with you. So First thing I wanted to do is we're going to focus on querying the order table and the order items table. So what I'm going to do now to get ready for that, I'm going to go ahead and create a models folder. And then here, I'm going to go ahead and add a class for the order table. Just so here we have the order table. What I've done is I've taken, let me flip over to SQL. So I created a class with the same fields that we're going to return back from our query. So here we have order ID, customer ID, order status, order ID, customer ID, order status, etc. So I went down the field. So these integers, we got the date time fields. And so here's the data we're going to return back for the order. Let me go ahead and I'm going to add another class for order item under models. And then okay. So here's the order item. And so here are the fields that are on the order item table. And I mentioned earlier that the table doesn't have a line item price. So what I just built a derived column where we're going to calculate that based on the object values. Okay. So first, what I'd like to do is I would like to show, let's take a look at what it means to query to get a list of orders using ADO.NET. Right, so I'll go ahead and then for here, now this, okay, so now that I have the classes in place, and this is ADO.NET code that you have most likely seen or written in the past. Now let me fix some of these compilation errors. Let me insert the using for the collections object. Oh, what I need to do. So if we're going to use ADO.NET, let me manage NuGet packages for solution and go Microsoft.data.SQL client. Yep. Here, I'll go ahead and select. It'll add a whole slew of assemblies. Okay. So now that I've added that, let me do the using statements for SQL connection. Okay. So here we're going to list all the orders. The result is going to be a list of the order object. And here you have the query, select, top 10 from asterisk from sales orders. You've got your, you use the using statement for the SQL connection. You open the connection, you build your command, you define the command type, the command timeout. And in this case, we're going to open a reader. We're going to execute that statement and get the reader. And then while we read, and it's going to read every record in that result set, perform some kind of mapping into that custom object, add the results. And then at the very end, it's going to take that result and it'll print out the result. So pretty straightforward. Here, I'll go ahead and run this. So it queries the database and it found the first 10 orders in the system. And there's order ID 1, 2, 3, 4, 5 to 10, and then the various dates the order was placed and shipped. So pretty straightforward, right? Now, let's go ahead. So I'll comment that out. Now let's take a look at what it means to do this in Dapper. So, load orders Dapper via text. Oops. Let me generate that method. Okay, so now for Dapper, if I go to NuGet, and I search for Dapper, And here, take a look. There's lots of other Dapper libraries where people have looked to extend the reach and the capabilities within Dapper, but right now we're just going to focus on the first one. It's at least 69.6 million downloads. So I select that and go ahead and install it. Okay, it is installed. Let me close these. Okay. So now let me show you what it's like. Let's see, show you the difference between the raw kind of ADO.NET. So I'll just do this. So let's take that ADO.NET code, and I can show you how this changes. So here we can see we've got the same my result. In fact, you don't even have to do you don't even have to new it up. We can just call this and say my result. You can have the query definition here. Select top 10 from sales orders. You can still have the same using command, but in Dapper, you don't need to, outside of using transactions, you don't need to distinctively, or you don't have to open the command. You can do that by default. You can reduce this down to, so you have my result, which is the variable we defined up here, is we go to that connection. So here is where the extension methods are. So when I go to con, I get a query, oh, hold on, using Dapper. Okay. And actually, let me put in using Dapper models. Okay, or Dapper demo. Okay, so I have the using statement for Dapper. So now, yeah. So now if I go to connection dot, now you see all the series of extension methods that Dapper adds in. So there's, I'm going to do a lot of synchronous examples, query, query multiple, et cetera. There's asynchronous ones that can help help you as well if you want to build this asynchronously. But you'll see there's a series of queries. There's also there's execute, and there's some other overloads as well. So we're going to go ahead and take, we're going to use query. Now you want to pass it a type of what you're expecting. So in this example, we're expecting order, the order object, parentheses, parentheses, and then we're going to return a list. So I'm going to convert it to list with two lists. And then in the inside, now you can pass in the properties. So I can go SQL, and I can pass it in query, command timeout 90, command type. Oops. So command type dot, in this case, we're going to do text. Oh, nope, my bad, text. And that's it. So with that, I can delete these entries. And most importantly, all that goes away, and that goes away as well. So now I was just able to add the using link clause up top. So now I was able to convert that query down to literally those handful of lines of code. So let me run this. I'll do Dapper, save it. And when I run this, you'll see it just ran through the same ones. So it's just so much time. I don't know if many of you, if you've built your infrastructure layer or your data layers where you're having to do like using raw ADO.NET, man, you're constantly having to write that mapping code. It's just after a while, it's plumbing and it's tedious, and wishing I had CodeSmith or something that will allow me to generate that stuff, right? Well, Dapper by its mapping allows for that, so it's kind of nice. Okay, so that's a good example of how to use Dapper for loading multiple records. Let's see what else we have. Now let's do that same query, but within a stored procedure. So I'll do load orders via Dapper Sprock. So calling a stored procedure is not that different from actually calling it within, here, I'll copy this. So if I go out to the database and I look in programmability, let's see, so get most recent orders. Let me see if this is it. Yeah, this is it. So I can take this stored procedure name. I literally change that to the stored procedure name. And then I change this to stored procedure. Run it. And you'll get the same result. So it actually will map the values from the stored procedure. So just with a few small tweaks, we'll get you, we'll provide you the ability to execute with a stored procedure. Okay. So that's that's a good example of being able to load the orders via a to get multiple results. But now there's sometimes when you want to get one result, you want to get the object itself. So let's take a look at that. So now if you want to get single load order via text, I'm going to pass in a 1, and that's going to represent the order ID that I want to return. So generated that method. So here, copy this code. Okay, so we want to get a single order back from the system. So I'll change the definition to order ID. Okay, I'm going to load order via text. So what we're going to return is not a list of orders. It's going to be a specific order. So I'll call that my result. So I remove the list definition from it. From the query, we'll go ahead and use this. So select asterisk from orders where order ID equals order ID. So what I would like to share is another one of those. Please don't do it the way we're looking at it here. I would ask you, please, 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 please don't be tempted to do this. Right. So there are some that use string concatenation to build SQL, and I can't stress enough, like, please, please, please don't do that. Because you imagine if this variable was, if the input variable or string, it just totally opens you up to, or it's susceptible to SQL injection. So, oh, I lost my spot. Sorry, hold on. So not to get all on a security tangent, but this is where if for some reason you're passing in a variable, it's too easy for someone to make, order ID equal to order ID equals 0 or 1 equal 1, semicolon, drop database like stores. And if you happen to be connecting to your database with SA or some other admin account, you're in a world of hurt. So, what I would again recommending for strings, just one way that you can protect yourself is through using parameterized queries. So in Dapper, you can do that with an object a Dapper object called dynamic parameters. So, sorry, let me do this. Okay, I'm going to get rid of. Okay, so I have the query select asterisk from sales.orders where order ID equals the parameter order ID. So for Dapper, you create var qp equal to new dynamic I had using Dapper up top. All right. So there's dynamic parameters, and here qp.add, and then here this is again probably very similar to how you may have built parameters in the past. But here a parameter has a name, it has a DB type of DB type.int 32. You can define a parameter's direction. So direction can be an input parameter, an output parameter, input output parameter, or return value. We'll look at return value in a minute. So this is an input parameter. And here I'm going to do the value. I'm going to pass in the value that's order ID, which is the variable defined in line 49 above. Okay. So now, I must have commented that out. Okay, so now we keep our same using connection. So we're returning one record back. So we don't need the to list because we're not returning a single list. And for here, we're going to call the query first or default method, and we're accepting an order object, or we're expecting an order object to be returned as a result of this query. Now the difference is now you just pass in parameter or PARAM : QP, comma, and that's it. And then so for here, I can just return. So that logit message is just going to say order. Since I remove the looping through each one since we don't have a collection. So this is just going to say order 1 was placed at whatever date and shipped on whatever date. Okay. But essentially to change it from returning a multiple records to a single result, again, I just changed the query to first or default, removed the to list, and then the type is it's just returning the order object. So if I run this, oh, that's what it was. Okay. I thought I did something. And that's why I'm copying over some things. So you don't have to watch me code or watch me type. Oh, and I changed this to text. I had it as stored procedure. There you go. So then it shows that order 1 was placed on this date and that date. So I hope you're seeing that it's a trivial amount of code to be able to run some queries. It's kind of nice to not have to deal with that mapping logic all the time. But okay, so let's see. The next thing I wanted to show you is there are some entity framework. One of the advantages of true ORM is that it can handle it handles relationships between tables really well. And another one of those kind of database stipulations that we always try to recommend for performance, try not to do select star from these tables because you're returning, especially if you're returning a ton of records, you're returning a whole bunch of fields. If you only need a couple fields from that, don't bring everything over. Just do a partial. Write your query to return only those fields that you need and go ahead and result. So I wanted to show two things with this. So first is, let's say you have a, well, so there's a sprock. I have a sprock in here, which is get order summary. So in this case, it's returning the order field plus it's returning the name, the full name of the customer and the sales associate. So I did this for a purpose. I want to show you this. So what I'll go ahead and do, there's a customer name, a store name, and a sales associate. So we're 3 additional fields. So let me go ahead and create, I'll take this order. So I'm going to make a duplicate copy of this order. I'm going to call it order summary. Right, so I go here to order summary. And then I want to add, I'm going to add 3 different properties to it. There's store name, there's customer full name. And the other one was sales associate full name. Okay. And so in this example, the sprock is sales order summary. So let's try this. Here I'm going to do load summary via sprock. So let me create this. Okay, let me just save that Sprock name. So now I'm going to go ahead and change this. So I'll take this, now I'm going to take the stored procedure name and I'm going to define that as the query. Oops. It has a parameter called order ID and I'm passing it in. Okay. So it's going to return, instead of an order object, it's going to return the order summary object, right? So it calls get order summary, it passes in an order ID. And so I'll change this to stored procedure. And it's yelling because it has the different discrepancy from the order object. So here we're just, we're going to run the same query first or default, calling this stored procedure. And let's say I want to change this to, let's say we want a message called, what's a good example? Order, my result order ID was placed by, I'll call it, it was placed by, order ID from store name by, and I'll do my result dot sales associate, no, customer first name. No, that's right, sales. For this customer. Anyway, I just wanted to show you an example of returning fields back. So we'll go ahead and run this. And here it says order one from Santa Cruz Bikes by Mary Copeland for Jonathan Velasquez, where Jonathan's a customer, okay? One of the, now this doesn't really fall into good database performance issues, but I mentioned earlier, like have a query that only returns the fields you need. One of the things about Dapper is that, for example, as you noticed, I didn't need, the only fields I used for the summary object was order ID, store name, customer name, full name, and sales associate. So you can build a class that only has a handful of the properties from the query. So if I run it, it's not going to fail. It found objects that sorry, and it runs. And so the fact that I had an object that only had some of the fields that this class cares about, that's totally fine. It'll still run. So a database purist or performance purist would tell you, you know what, just write a separate query that only returns those fields you need. Because in this example, it's only returning one record. But imagine if it was returning tens or hundreds of thousands. That's a bunch of data being marshaled over the wire that you don't need for that particular purpose. So anyway, but I just wanted to demonstrate the fact that in Dapper, you don't have the objects, your objects that you map into don't have to have every single field. If you're only looking for a partial, you can do that as well. Okay. All right, so I'll go back to the program. So another way, this isn't as elegant as this, what I'm about to show you is not as elegant of a solution as like Entity Framework and some of the others, but a lot of times you're dealing with a parent, a parent entity that has child entities of basic. In this case, we're talking order and order items. So there is one approach to this, and I can, I'll show you this. Let's see. Here, this is one that and I'll walk you through this one. So I called this get order and line items, and I'm passing in the one again for the order ID. So let me, there we go. Okay. So in this example, Dapper allows you to run queries or stored procedures that will execute and return multiple result sets. And how it does that is there's an extension method called query multiple. So in this example, you're returning, ultimately, it's going to return an order object, but also order line items object. Oh, yeah, let me do that. So if I go to the order object, let me uncomment that out. So now my custom order object has a list of order item collection called order items. Okay, so now that I've enabled that in the object, now let's take a look. So the query itself, what you see here is there's two queries stacked on top of each other. One will bring you will return the one order, and the next will return you the multiple order items. So here we have a dynamic parameter where we're passing in the order ID where this information is defined. Same using clause you've seen before. Same type of call. The difference here is we're issuing a query multiple, not just the query. And what happens is from that result, you can cast it as follows. So you assign your object, order equals, in this example, the multi, which is the result, multi.read, and you give it the type of what object type that you're expecting back for that. In this case, we know we're going to get one back, single. So we use single. For order items, here where we issue the same multi-read, I'm expecting an order item back, and then here I call the to list on it. So by doing that, and I can set a breakpoint so we can take a look at this. I'll go ahead and run it. Oh, so here we are at the breakpoint, and I'll go ahead and take a look at the order. And so now we have our order one we've been looking at for this parts of the demo. And here are the order items. In this case, we have 3 order items. And I thought there were 5. That's why I'm pausing for a second. But anyway, I'll come back to that. So yep, now we have an object that has our order, and then we have order items. We have this information here, and each of those are it retrieved the values from the table. So now what I did in the method after I obtained that information, I'm now using I'm summing up the values of the line item price. And if you remember, line item price is that derived column, which took the list price and subtracted the discount to get the line item price. So this is so all I'm doing in this method here is I'm summing up those amounts, and I'm just going to display this amount here at the end. So let me hit F5. And oops, I need to format, but order one has 3 line items at a total cost of $4,563. Okay, so need to format that. But anyway, so that's one way to get your kind of parent and child relationships. Not the best, but it's a way that you could consider. Another option would be if you had a separate query for that, you could, within the same using statement, be able to query to get your object and then whatever your parent object and whatever child object you would need. You can call those as well. Okay, great. We've talked so much about querying. That kind of, I believe, covers the majority of the query type examples you'll have. How are we doing on time? So pretty good. Okay. So now I want to spend a few minutes and talk a little bit about updating. What does that look like? Performing inserts and updates, and I want to bring up a few concepts of transactions and looking at return values, etc. So what we're going to do from the database perspective, it's just something really simple. There is a table in the production environment called brands. Here, let me do this. So asterisk from production.brands. Okay. So this is essentially a lookup table, right? These are the brands of bicycles that we this retail location sells. So what I'd like to do is to go through some examples here. Since we're going to be dealing with brands, I'll go ahead and create a class, brand.cs. And here, I'll create int for brand ID, string brand name. Let me make sure that's what it's called. Yeah, brand name. Okay. So I have my entity class. Now, if I go back to the program, so now for update with text, I'm going to call this, first we're going to, just for the demo, I'm going to var up b or var b equals new brand. And for this, we're going to say for what we're going to do is that for Heller has now been acquired. So brand ID is going to be equal to 3, comma, brand name is equal to Metallica. So Metallica has acquired and want to create Metallica bikes. So that's their brand name. And so what we're going to do is we're going to go ahead and update brand via text, and we're going to pass in that B. Okay. All right. So we're going to call that. I called it something a little bit different. Okay. So we're going to update the brand with text, and we're passing in that B object. So this simply is going to perform an update statement, set brand name equal to Metallica, where brand ID equals to 3. Okay. So let me walk you through this, and it's pretty straightforward. Again, a lot of this should look very similar to what you've just seen. I'll talk about result in a minute, but here's the query. We're gonna perform a text-based query. We define the dynamic parameters that are included within the query. You have your same using statement we've been using that we've included. Now this is a little different. So instead of query or query multiple, you're executing an extension method called execute. And that execute, you can still, I just happen to have the parameters in the same location, but you can call them like we did before. But you pass in the query. Next, you pass in the query parameters. Next in this signature is a transaction. I'll show you that in a minute. Next is the command timeout. So if we want to keep this at 60 seconds or whatever, we can do that. And you pass in the command type, right? So that one execute statement, this will perform the update. What it will return is the result of how many records were affected by this command. So that's true as long as, like, if you have a stored procedure where set no count is turned on, it won't return the actual number of records affected by. So you'll have to look, and I'll show you about a return result. There's a different way you can find out whether that was successful or not. But in this example, it's going to return with a result of 1 because it updated 1 record because it matched within that query. Okay, so I'll go ahead and run this. And brand updated with the result of 1. Again, 1 is for 1 record that it updated. And now if I query the table, you'll see that record 3 was changed to Metallica. Okay. Now, next we're going to do the same query, and let's say Metallica got acquired by the great Iron Maiden. So Iron Maiden's going to start selling these bikes. Yes, I am a metalhead at heart. Okay, so the next thing we're going to do, I want to introduce transactions. So I'm going to call this method update brand name with texts. Oh, with text with transactions and TRX. Okay, so transactions. It's probably safe to assume many of you who've been working with databases have run into this before. You want to, you're maybe doing a whole bunch of things, and if something fails, right, you're taking a bunch of actions on traversing through result sets, et cetera. And if one thing fails, you don't want the rest to go into the database. Great way to handle that is through a database transaction. If you're doing 7 steps and something fails in the middle, you want to revert that, make sure those changes are not committed to the database, interrogate, go figure out what's going on and try to fix the issue. So a good way to do that. Transactions are fully supported within Dapper. So now let's take a look at this. So with text and TRX. Okay. So a couple nuances with Dapper and transactions. So first and foremost, you have to ensure if you can't start a transaction unless the connection is open. So there are times you may have to explicitly DB open. Right? You may have to call database open to be explicit. Technically, you probably should do if, right, db dot set state is equal to, or actually, if not, db state is, oops. db.state equal to, oh, what is it? What, I'm trying to think of that command. Oh my gosh, why have I forgotten this? db state is equal to SQL connection dot, is it? No, I forgot. There's a way you can measure the state on the connection. If it's closed, go ahead and open it. But for the purpose of this, we're going to go ahead and open a transaction. I'm sorry, and open a database connection. And now you do var trx equal to db dot begin transaction. So now you have a reference to that transaction. And if you remember, I ran the query, and the third parameter in this query, oops, was the actual the IDB transaction. So you passed in trx here, where I executed it, right? So now we can execute this transaction, and then you can check to see, oh wait, let me do it inside. Then you say, if, for example, result is greater than 1, no, greater than 0, then we know it's successful. Go ahead and trx.commit the transaction, else trx.abort, rollback, not abort. So you can roll back a transaction, right? So then db.close, and then you close your database connection.
So Scott, we have a question. Would Dapper support transaction scope?
Yes, and I found out the hard way actually yesterday. I ran into a scenario where I was performing a function where I'm calling lots of store procedures, right? So I was like 6 calls, and it does support transaction scope. But if, for example, one of your store, like I ran into one of the stored procedures that like the 5th of the 6 I was trying to call actually does a commit, then it'll throw an exception, because if one of your sprocs already has a commit transaction, it'll get committed there. And then once you go back and then try to issue a commit, it's going to fail and say like, whoa, the transaction count has changed from what I thought it was before you entered this call into now. So that's something to keep, you have to keep in mind. Like you'll have to in this example, you'll like, for what I would want to do, I'd have to then make a copy of that sproc that didn't use the commit and the rollback, so that I could do it all here within this entry. But if you commit it midway through, you're going to run into an issue. I hope that answers the question. So if I look at, so one of the things I want to do just to show transactions will work, just for grins, I'm going to go trx.rollback. I'm going to go ahead, even if it's successful, I'll roll back the transaction. And you can imagine what's going to happen is that Iron Maiden will not get written to the table, and it will stay as Metallica. Okay, so I'll go ahead and make sure this is, run this. And so it says it was updated with the result, but that's just static text. And now if I look at the query and I run the same query again, record 3 still stayed at Metallica because we rolled back the transaction. So conversely, if I change it, go ahead and issue a commit if it works, F5. And if I go back to the database, now 3 is Iron Maiden. So just to show you, transactions really do work. So it's kind of nice when you have to, when you're able to perform those additional functions. So, okay, let's see. So if I mentioned earlier, change this to Anthrax. Okay, so Anthrax acquires Iron Maiden. Yeah, imagine that. Okay, so now the next demo, or the next thing I wanted to show was introduce the concept of return values. So for here, let's see, minimize this, minimize some of these. Okay, I wanted to introduce this concept of return values. So I'll go ahead and pass this in. So here we're gonna, we will call a sprock here. I'm gonna pass in B. Okay, so again, I mentioned that the whole idea is a return value from an execute statement typically has the number of records that were updated in the query. But if that store procedure has set no count on, then it will not return that. So you need another way to kind of know whether your command was successful. Let's go ahead and take a look real quick at this store procedure, which is production update brands. So let me go production update brands. So in here's an example of here's an example of this store procedure has the set now count on, and it has, and here we're returning, where it performs an update statement, and this runs for SQL Server. It's running the @ error symbol, and that will give you, in the context of this query, if there were any errors, if everything was successful, it'll return a 0. If there were any errors commands, it'll return something other than a 0. So from the code perspective, what you'll see that's different in this scenario is line 71 here, that shows that there is a new value, and it's not, ironically, it's not defined @ error. It's just a kind of a reserve name for the ret val. It's going to be the parameter direction of return value, right? So that's a little bit different. So it's an integer, it's a return value. And then we're passing it into the query as we expected. And what you do is after the execution, you can assign the variable by saying query parameters.get casted or of type integer. And what I want you to return is the variable ret val, which I defined up here as being the return value. And now I can check that my return value, if it's equal to 0, if it performed the update, then great, it does the commit, else the rollback. So I'll set a breakpoint here so we can take a look. So here you've got the database connection object. Opening, beginning a transaction. I perform the execute. So once it's done, my return value is set to 0. So I know that was successful. So I'm here. I'm going to go ahead and commit the change. I'm going to close the transaction, and then I get out. And now if I go query the database, the third entry is now changed to anthrax. So again, just to show, it's a different way to get return values. I know through DBAs, I've learned that setting no count on supposedly increases performance. That's what I've kind of believed to be the case. I think others could probably verify that or call me on in case that's not the case. But I believe it is. At least that's what I've learned in the past. So maybe that's changed over different SQL Server versions. But anyway, so that's another way to get to obtain some kind of notice if your execution was successful or not. Okay. Let's see, insert. Let me take a look at this. Okay, this is one kind of cool thing about, I'm gonna do this. Okay, another neat thing about Dapper is it allows you to, well, you start with one statement. In this case, we're inserting into production brands a brand name and values of A. Now that A can be a collection. So in this example, let's say I would put, let's try U2, excuse me, U2. Yeah, let's see what else I want to do. And then if you, let's see what I want to do. What else I want to do? Yeah, sorry. So you can, what it'll do, sorry, is that you can execute, Dapper will essentially translate this. So if it finds the multiple values passed in as the string array, it will translate it to multiple SQL statements, and it'll execute it as such. So what appears to be in this account, we're saying, hey, go ahead and execute run this insert statement. And then if you pass in a string array, it'll translate to multiple insertions, and then it'll execute those. So that's one example. We're doing on time. All right, I did want to show you. Let me come back to this. I wanted to simulate in this example. I want to simulate an error. So, all right, let me do this. Error and exception handling. The nice thing about Dapper is you're dealing in the world of, you're in C#, right? So you have your common debugging mechanisms. You can build integration tests around if you need to, but you're in the land of C#, so you can debug and you can perform those items. Hold on. And I had an extension method that I would actually would pull out the inner exception error. But I want to focus on this. So in this example, we have this method. So list data but error. In this example, I'm trying to force an exception by dividing 1 by 0. And so that'll trigger an error. And I just wanted to show that the nice thing about Dapper is you're in the world you're normally in the sense that you can handle, you can put try catches and handle certain exceptions and manage those appropriately. So for example, there's one where, again, I'm going to force this error. We can go ahead and I can set a breakpoint, go ahead and run it. So now if I go, so I'm going to try to perform the query, and you'll notice that it kicked out with a SQL exception, and that exception was a divide by 0 encountered. So again, you can wrap your try catches, you can manage all that. If you are explicitly opening your connections, make sure to do a finally outside the catch and close it. Make sure your connections are closed if you need to, etc. So that's one exception. I think another one we could follow through to show you the error. Another one would be, let me try to do this. I'll just adjust the database name so the database doesn't exist and it can't open it. So now if we try to do this, okay. It should come back with another error. I was hoping that it would trigger. Oh, so it's still, yeah, that's right. It would be a SQL exception because can't open database requested by the login. The login failed for the user. So anyway, so it's good. You can wrapper, again, you can subclass your exceptions and be able to handle them accordingly. So it's it's a familiar space when it comes to C# development. Okay, and then last thing I wanted to show, this is more of a preference. I started digging into, I found an example of Jimmy Bogart's where he redeveloped the Microsoft's Contoso application the way he would want to build it. So I have a link for it. It's actually a hidden slide, but one of the things I started getting into is feature slices and looking at MVC and APIs. And what I started grouping all the models together and all the commands and all these things. And what I found, and any of you that may have done that in a project, some of the challenges are, you're just looking, oh, let me go get the request, and then here's the response, and you're kind of searching all over for code. And what I found is I started gravitating towards grouping the like projects together and keeping them. You have feature slices, and another way, and this is more of a design aspect, but I wanted to show an example. So so I'm going to add a folder. Imagine you have an infrastructure library. You have queries, for example. So I'm going to create a query. I'll just call it get orders, right? So I just want to show you, and this is something where I've it's kind of the next step of like, okay, I get Dapper, like I understand how to use it. How can I kind of structure this? And so what this is it's a class called getOrder. In this example, you can either, use dependency injection, or I'm passing in a connection string, or there may be better ways for you to handle that in your application. But the idea is this actual class represents everything that's needed to run this query. So it contains your request. So here are the values that I need to send to the query. It's a subclass within the getOrder query. So here's my request. This is the data that I need to provide you. Here's a response. And so the response has some properties that you would like to return in an API call. For example, was this query successful? Like, did it process to completion successfully? Does it have a value? And if not, what was the error message? And then here's the data, what you're returning back. In this case, is an order object, right? And so then the class has a method just called execute. And there's that we pass in the request, and then here's the response. And then the Dapper code, it's really similar code that you've seen through most of this demo, right? For the using, query first, or default. And the difference is I'm just populating basic fields within that response object and returning it back. So again, it's more of a syntactical sugar, or like a design approach. But one of the things I've started gravitating to more queries like this, because I love that it's all in one class and it uses a subclass, and there's no question of what requests or responses are needed. So just more of a design aspect here. So any questions before we continue?
No, but Parks thinks that project design is a great topic.
Cool. I think it would, well, so, and that's where I want to highlight this a little bit. I do think there's a, okay, cool, I get Dapper. Like, I understand it's pretty straightforward. Like, how do I take that the next step? And that actually is a talk I would love to give at another time, which is where we could, and I'll talk about it. There's some additional topics. There's some additional topics, which, like, kind of designing your data and infrastructure layer. I don't know how many of you have spent time with, like, Steve Smith is promoting clean architecture. You may be using your own kind of, there's onion architecture, there's clean architecture, and where that factors into design, it's kind of fun. Again, my last project, which was a total greenfield project for us, we were able to use, again, entity framework in the repository pattern, was able to use a unit of work. And then it meshed really well. Entity framework was a great, at the time, was a great solution for us for that. But Dapper was fantastic for us for reads because it was so fast. Whereas our current environment, again, we have some databases that have been around a while, and they're sizable, and there's lots of the back end in the back end. So EF would have been a little bit more challenging for us. It could be done. I'm not saying it couldn't, but it would be a lot more challenging. So Dapper just fit in nicely, and it's really kind of paid off wonders for us. So, so this is, I'm sure many of you share these opinions. For some, EF versus Dapper, ORM versus micro-ORM is a pretty passionate belief. And I'm not there. I'm not going to bash EF. I can tell you I enjoy working with Dapper more. I feel like I can get to where I want to be quicker than I can by setting up EF, but that's not a knock on that, because I think, in my opinion, I think they're both very functional data access and object mapping techniques. Again, this is the world according to Scott View. And the more if you're interested and you start researching this topic more, if there are any people here who listen to the sports radio, The Ticket, I'll use the phrase hot sports opinions. There's a lot of hot sports opinions about ORM versus micro-ORM. Some believe that, ORMs are good for, micro-ORMs are good for just like utility application, but ORM's the way to go. I don't subscribe to that theory. I think they both work well, but I think there's two things you need to look at. Of course, you need any technical platform you choose, or any technical component you choose. You want to make sure that it aligns with the functional requirements. It brings the functional requirements to life, and you can honor the commitment you are making on the application, to the end users, and making sure it makes those kind of dreams a reality. But I do believe it's totally an environmental fit. If folks can take a second and jump back over to the participants, I wanted to ask a question. How many of you have worked in a, mid-sized to large application for or a team or company that has a DBA team? I'm curious how many people. Okay, so about a quarter, a fourth of it. So hopefully this will resonate then. So I think again, I believe, I've always said like every IT environment is a unicorn, right? So, but there are some similarities, right? For smaller organizations, you may be on this call, you may be the sole person responsible for building this application, right? You may be from design, inception, development, testing, implementation, and support. You've got it all. And if you're a full timer with that organization, then great. Then as long as you feel like you can continue to support it, I think it's awesome. You can pick whichever, whether it's Entity Framework, Dapper, or what other technology. But for smaller organizations, typically some of the, not always, but some of the projects are new projects, or you're dealing with a greenfield kind of application where you can build everything from scratch. So if you or your team members are well versed in C#, and feel that you can take on the responsibilities of an ORM, then have at it. I think you'll be successful. So for the 5 or 6 folks that raised their hand, and I can raise mine. I was one of those where I've worked in an environment that I wanted to ask how many people of those people that raised their hands, how many people had to submit interface contracts to DBAs that said, here's the query I want. Because there's sometimes the partnerships with DBAs can be very strong, and there's some that can be a little bit adversarial, where they're, we'll build you the stored procedures. You just tell me what you need, and I'll give you the sprocs, and I'll build it, because they like that layer of abstraction, right? They like the fact that they have more control over fine tuning performance, so it doesn't require an application change. It's a very passionate topic, but I think some environments there's a great partnership. I've worked in some. I've worked in some where it was a little bit adversarial, so you had to find that happy medium that works between the teams. But databases can exist. They can exist for a while. They've built and grown and organically grown over time. Yeah, the database may consistently or inconsistently have some business logic that you have to account for in your application. Some may have lots of joins. There's complex queries. To get to the data you need may take lots and lots of joins, and that is where I still have much to learn on any framework when it comes to fine-tuning queries. I personally had problems with Entity Framework when it came to some of these complex joins and understanding what happens under the covers. We had these pages and views that were taking a while to load, and so I'd load up SQL Profiler, right? And we'd have SQL Profile, we'd run, we'd watch and see what's happening. Show me all the queries that are taking longer than 10 seconds to run, and none of them would show up. But then we looked, and it was like 100 queries would execute under the covers. And so it was, like I said, I'm not an Entity Framework expert, and I felt like there was a lot to learn as far as a fine-tuning perspective. But along those lines, Tim Corey wrote an article about Entity Framework versus Dapper and what he recommends. My big takeaway from this article that's referenced wasn't really so much the feelings of where it's good and bad, but like the idea that we as developers, architects, development leads, etc., we need to look at whatever technology you choose. You have to look at the team and how the team can embrace a different technology. So I can answer these from the Dapper perspective, right? So when you're considering your approach to using Dapper, does your team understand how to use Dapper well? I hope the demos have showed it's pretty straightforward to implement within Dapper. There's low barriers to use, and there's not a whole lot you need to kind of get started. Does your team know how to diagnose issues with Dapper code? Well, I hope the demo showed that you can debug, F5 debug, and you can, there's no generated code, so you can debug with your SQL techniques or with your common .NET techniques. Do you know how to diagnose underperforming Dapper queries to fix them? Well, your Dapper queries are your SQL queries. So hopefully if you wrote them, great, you can fine tune those. If not, you can work with someone on the team or somebody on the database team to help out if you need to. Does your team understand the code that Dapper wrote for you well enough to know what it's doing? Well, the good news is Dapper doesn't have any generated code. So Of course, you'll need to, you probably research and see if you're fine tuning performance, you may have to get a little bit deeper under the covers, but we've yet to do it, and we've been rolling out Dapper quite a bit in our organization. So there may be a chance there, but for the most part, Dapper doesn't generate any code for you. So there's nothing that doesn't really apply. And then lastly, do you know how to protect Dapper credentials on client machines? Well, this is no different from ADO.NET, Dapper, ORM, or EF. The recommendations, right, are encrypted. Please don't store that information in source code, but put it in somewhere else, whether it's Amazon KMS, right, Azure Key Vault, cloud configuration within your web app, server variables, or someone just outside of the application. But that's no different from any other technology. There's nothing really specific about that. We're doing pretty well in time. I did want to just go through a few of the slides. These will be really quick. So taking this, so once you get through, again, you get through this, you're like, yeah, cool, Dapper's great. How can I implement it on some kind of live applications? First, I wanted to share that Dapper, Dapper is focused on the 95%, which is the queries, commands, and object mapping. There are other packages that exist where people are attempting to extend some of the functionality that are in ORMs. So here's that same table I showed earlier with a few different properties of Dapper.mapper works with helping to build the relationships between objects. Dapper.contrib gives you the ability to provide change tracking on some of your entities. So that may be something you want to look at. So some of these numbers I think need to be updated, but here's an example of some others. Again, if you just search Dapper and NuGet, you'll see some of the additional properties the additional packages that are available to you as a developer. If I can't remember if I asked this before. Last time I'll ask you, by a show of hands, how many people are working on cloud-based applications? I see Dave, Eric. Okay. Okay, so those of you that have raised your hands, the chances are you've probably run into the concept of transient errors a bit. And so these, if you haven't, or if this term is new, I'm not going to read this slide for verbatim, but the idea is when you're in a cloud-based environment, especially like if you're running serverless architecture, we're running applications as a service or database as a service, for example, especially if you're in those lower tiers of performance, their platform is moving around compute power to who needs it, right? So it could be that if your site's dormant, but somebody else in your near vicinity wants to execute, Azure, AWS, whoever, they'll grab some compute power, take it away, apply it over there real quick, and then bring it back. Well, what happens is these transient errors occur, like what happened to us in my last job at 3 in the morning. I got your database was unavailable, and the panic then is you're like, wait, no, why was that? So we learned about transient errors. So they're just, and they could be milliseconds, but they're periods in time where your database connections will drop, and you'll have temporary service interruptions as a result. So what does that mean is that your code will need that you'll want to look at fault tolerance. You'll want to look at implementing retry mechanisms. And Poly is a NuGet library that will help you in that. So I just wanted to share this with you. I didn't have a chance to demo it today. Maybe that's something we can look at in the next discussion. But Poly is a nice way to actually build some of those retry mechanisms. Next is this is where I believe I mentioned it before. I've leveraged so some of the next steps, like, okay, I get Dapper. How do I design this in a class library? And this is one thing. This is what I wanted to review and actually build a repository pattern using Dapper. If you're interested, tomorrow there are some content creators that have created this. I've referenced some of these articles here of how to build a repository pattern. But even this is a hot sports opinion. There's a lot of people they're like, oh, and don't use repository pattern, use this instead. So I think researching it, but I found that it was a pretty clean and easy way for us to be able to manage. And once you get the hang of it, it's pretty straightforward. So if you guys will have me back, I would love to just sit down, no slides, all code, and we can actually build something like that together.
And if anybody wants those links, this is all being streamed to YouTube. And so that's all there for you if you just want to go look at the video that's there.
Awesome. And then I'll make sure this latest deck is up on my GitHub in case anybody's interested. Again, but I hope tonight I've introduced Dapper as an alternative to, or a solution for accessing data and object mapping. I hope we talked a little bit about best fit scenarios. I guess my last point on that, I personally just don't subscribe to ORM should be just in utility applications or micro-ORMs or in this world. I think it's a little bit more open-ended. I sound like a consultant, like, well, it depends. But I believe you just have to look at multiple factors, I think, to make that determination. And if you want to dive in more, I have some additional references here. Some of these are training courses as I was diving into it, and our team was diving in and learning more about Dapper. I have this information here. A couple articles that I referenced within the talk. And that's my GitHub repo. And again, the sample code is out there. I'll update the slide deck, and I'll try to get that up there by tomorrow morning. Hopefully I get it done tonight after the session. But I really thank you and appreciate your time. I hope this was something that you're interested in and or maybe has piqued some interest. And if anybody has any questions, I'm happy to answer and try to answer them.
Thank you, Scott. There was one question left over I don't think we asked. Does Dapper support SQL encryption?
I was going to answer yes, but I guess it depends if the encryption is outside. If it's outside of. So let me preface it. I have not run into a scenario where the data, by the time Dapper pulls it back, that data has been decrypted, and so I don't know if others on the squad can, or on this meeting can answer if they've run into it before. So I have not encountered that, so I apologize. I don't know the exact answer. I don't want to blindly say I believe so, but I think that's a great research topic that I'll see what I can find out.
Cool.
I'd hate to blindly say yes and be wrong, or blindly say no and be wrong.
Oh, one more question.
Sure.
Can we run queries in parallel in Dapper?
Yes. So so yes, you totally can. So for example, we have APIs where we're running this, and you can handle concurrent connections. You can also wire up all of those extension methods I showed. There are async values of each one of those. So you can run those asynchronously as well. So and it works well. And again, we have an infrastructure class libraries that serve as our infrastructure layer that's called by our core layer, and which is then called through the web, like web API, for example. So yes, you can.
Thanks. All right, that's it for the questions.
Okay.
Thank you, Scott. We really appreciate you coming and presenting. Anybody have any last questions before we dismiss? If you haven't yet, please, if you're in our Slack channel, go in and vote on next month's topic. And if you're not in our Slack channel, you can join the Slack channel. It's in the link to join that is in the comments. And so if you go vote on that, I'd appreciate it. I'll be sending that on to our speaker next month soon. Any last notes from you, David or Scott?
So one thing is that if you are not in our Slack organization, you can get on our Slack organization by going to northdallas.net, and we have a link to it on the right-hand side.
Yep. And Russell just put it again in the chat. So.
Oh, yep, there you go. Yeah, that too.
Good job, Russell. All right. Well, thanks everybody. Once again, thanks.
Join our Slack workspace right there.
Really appreciate it.
Yeah, I was looking for it.
Yeah, it's meetings and locations right down below a little bit there.
Oh yeah. Okay. Yep, right there.
That's it.
Awesome.
All right.
So
there you go.
Great.
Thanks you, Scott,
everybody.
So much.
If anybody has any questions or feedback, I'm absolutely would love to hear it. So thank you very much.
See you later.
Take care, everybody.